Hello class, welcome back to Statistics and Mathematics YouTube channel. In our last video we did binomial distribution. Today we are continuing from where we ended, and our main focus will be on multinomial distribution today. In our lesson for binomial distribution, we said that experiment is said to follow a binomial distribution if its experiment results in two of the outcomes, right? And we said that two outcomes is successes and failures, right? But what about if the outcome is more than two? What about if the outcome is more than two? If the outcome is more than two, can we still use the binomial distribution to solve that experiment? No. What we use is the multinomial distribution. So whenever our experiment is more than two, right? Whenever our outcome is more than two, we use what we call the multinomial distribution to analyze that problem, right? So for example, a survey might require the responses of approve, disapprove, or no opinion, right? You see, right now this outcome is more than two, right? We are having approve, disapprove, and no opinion, right? So here we can't use binomial distribution. We have to come and adopt multinomial distribution. And secondly, in another situation, a person may have a choice of one of five activities from Friday night, such as movie, dinner, basketball game, play, or party, right? So here we are having about five choices that the person can choose out, right? So here we cannot use binomial distribution to also solve, right? So all that we are saying that for binomial distributions it have only two outcomes, but for multinomial distribution, when this possible outcome is more than two, we use what we call the multinomial distribution. Since this situation have more than two possible outcomes for each trials, the binomial distribution cannot be used to compute the probabilities, right? So let's go to our worksheet, and then I will take you guys through the systematical PMM that we have for multinomial distribution. So here is our worksheet. Our PMF for multinomial distribution is n factorial, right? Is equal to n factorial divided by x1 factorial times x2 factorial times x3 factorial to xn factorial times p 1 raised to the power x1 times p2 raised to the power s2 times p3 raised to the power s3 times p4 raised to the power s4 to p x raised to the power x subscript small x. So at the end of the day, you will see that this is our PMF, right? But what's the meaning of the p? What's the meaning of the x? What's the meaning of the n, right? So we are saying that the n is the number of individual observations. Our x is equal to individual events in the experiment. And you will see that the individual experiment, when you sum them, the x1, x2, s3 are, once you sum them, the summation of the x1, s2, s3 up to infinity up to xn must be equal to n, and the probabilities of pi is called the probabilities of success. Once you sum all the probability of success, you are surely going to get 1, right? And then the multinomial distribution also have its own mean and variance, right? So for the mean for multinomial distribution is n times pi, right? N times pi, right? So it's trying to tell us that we are going to find the mean for each of the probability of success that pops up in the experiment, right? The n times pi, and then you have this one too. The variance to is n times pi times 1 minus pi, as you can see here, right? So this is how we can find our mean and then variance for multinomial distributions. So in our next videos, we are going to solve some examples and our multinomial distribution. So kindly get in touch. Please kindly subscribe, like, and then comment. Thank you for watching.